This meeting is being recorded.
In this next video from Chapter 16 on acid-base equilibria, we'll take a look at sample exercise 16 from the worksheet. And we're given here some information about an aqueous solution of dimethylamine. So we're told that we have this concentration here of that solution, so this 0.164 molar, and then the pH down here is 11.98. So we're given the structure here of dimethylamine that would be added to water. We have our equilibrium established, and we get this methyl ammonium species over here and hydroxide. So let's create an ice table right below here and see if we can create, what do we ask for here? The values of Kb and pKb from the information provided. All right, so how can we do this? We know that Kb is going to be the concentration of our product. So that's going to be the CH3 2NH2 plus. And then we have, cut off there for a second. And then we have our hydroxide ion concentration as well. And then below that we'll have our dimethylamine, our starting base here, weak base rather. So here we have our Kb expression, products of reactants. Let's plug in some values here. So we have our initial concentration given. We'll block this out. We'll assume that we have 0 and 0 of our products. And let's plug in our change. So minus x plus x plus x from the balanced equation. So at equilibrium, we're going to have 164 minus x, and then these values are x and x. So what else do we need, right? We need to solve for x using pH to find POH. So let's do that first. So if we know our pH is equal to 11.98, we know that 14 minus pH will give us POH. So we have a value for POH of 2.02. All right, so now how can we find our hydroxide ion concentration at equilibrium, you ask? How can we solve for x? Well, we can take 10 to the negative POH, which would be 10 to the negative 2.02, which is our POH value, and that will give us our hydroxide ion concentration, which is our x. And that we'll find, if we plug this in properly, is around 9.55 times 10 to the negative 3. So again, this is going to be our x value here. So now we can use this x to solve for our equilibrium concentration of our dimethylamine, etc. here. So let's plug in some of these values. So on top, we're going to have our two products. So we're going to have 9.55 times 10 to the negative 3. And we're going to square that because we have x squared for our products. And then down here, we're going to plug in 0.164 minus 9.55 times 10 to the negative 3. So we'll solve for this, and we will get our Kb is equal to approximately 5.9 times 10 to the negative 4. Now, we want to find our pKb as well, just like when we have hydroxide ion concentration and we want to find POH, we take the negative log. We can do that here to solve for pKb. It's going to be just the negative log of our Kb. So that will be equal to the negative log of 5.9 times 10 to the negative 4. And this turns out to be a pKb equal to 3.23.